Welcome to all of you. Today we will learn about the one of the important step of data pre-processing, and that is known as EDA, that is the exploratory data analysis. So this concept I have implemented by taking two different examples to demonstrate the idea behind this EDA analysis. So I have created two different videos which will narrate you, which will give you the walkthrough how this EDA basically is important and how this help us to find out the insights from the data sets.
Let's start our discussion. We are using car.csv file from Kaggle that contain car data like the company which made the car, model name, type of the car, where it is made, if it is all-wheel drive or front-wheel drive, maximum selling price, discounted price, number of cylinder, mileage, weight, length of the car, etc. are there as a part of this car.csv. So these are the features present in this car.csv. Now here we are going to learn about the EDA. So these are the essential libraries which I have imported. Now as a process of EDA, basically we perform this many steps. So there are basically these 5 initial steps which we perform under the EDA. The first step is knowing initial detail about the data. Then subsequently we just try to modify or remove the unwanted data. In next step we just try to retrieve the data. We try to perform the statistical analysis over the data frame. Then we just draw the graph and plot to find out the insights among the data set. So there is it has been seen that if you are having a good data but there is a bad machine learning algorithm, even though you used to get a better result. Instead, if you are having a bad data and if you are applying a good machine learning algorithm, this combination always give you the bad result. So what I want to say here is this data pre-processing is very important part, and here we have to spend most of the time to make our data suitable for the machine learning model. Now there is a saying that if I had 8 hours to chop down a tree, I would spend 6 hours sharpening my S. So this is very relevant in the perspective of this machine learning. So if you want to do a machine learning work, if you want to make a model, then we have to spend most of the time for making our data suitable for the machine learning model. So with this understanding, now let's move further and just try to perform the EDA. Now this is the first step of EDA. So we should know how many rows and columns are present in given data. So for that regard, we are having a method called shape. So after executing this command, you may see that there are 429 rows and 15 columns. We should also get some information about data like column name, their data type. So that can be that can be done by using this method called info. So this is my data frame .info. After executing this statement, you may see that there are total 429 rows and 15 column, and this data frame is going to be have a 15.4 plus KB store. That is a space is required for this data frame inside the memory. The column number is starting from 0 and it is ranging up to 14. Then the column name along with the number of non-null value in each column are also displayed over here. Now we can display the column name in form of array or a list in the in this way. Let's say if you want to display it in form of array, we are having this method called this car.columns.value. So this value, the column value will come in form of array. Same thing we can display in the form of list. So for that regard, we have to execute this statement. To display the first 5 row of the data set, we are having this method. So car.head. So by default, it will display the 5 initial row of that data frame. Similarly, if you want to see the initial 10 rows of the data frame, we have to pass this parameter inside this head method. So this will give you the initial 10 rows where we can see the data values, and we may have some glance about the data frame like this. We are also having similarly the tail method. So this will basically give you the last 5 row from the data frame. So you may see this last 5 rows are coming by executing this statement. So that is the last 5 row, and this is the corresponding value with respect to the column. Now here we are also having one good method, and I use it frequently because this will give you the sample. So actually randomly it will show, it will select the 5 rows and the corresponding column. So actually it is very useful for doing the comparison point of view. So after doing this first step, the next step is modifying or removing the unwanted data. Suppose we want to remove the column that do not contribute to our analysis. We can use this drop method of the data frame class. To remove only one column, pass the column name to the drop method. To remove multiple column name, we have to pass the column name in the form of list. So you may see here we are removing the multiple column. That's why we have passed it in form of list. So after executing it, this MSRP and invoice is going to be delete from the data frame. Now here the x is equal to 1 indicate to take the total column while dropping it. To keep only one row and remove all its other duplicate, we can use drop underscore duplicates method on the car data frame object as like this. So we can also find how many rows are having a missing value in each column by executing this statement. So here you may see that cylinder column has 2 rows with a missing value. To delete this row, we can use method called drop NA. So here in place is equal to true indicate that rows are deleted in the same data frame. If this attribute is not given, then the row are deleted and remaining rows are returned, which need to be stored into another data frame. It is also possible to sort the row depending on the column into ascending or descending order using sort underscore values method. This will sort all the rows depending on the MPG, that is nothing but the miles per gallon in city, into the, here we have put the ascending is equal to false. So basically it will arrange the value in descending order, right? So here you may see the MPG city. This is my MPG city value. These values are sorted in a descending order. So after this, let's see how to modify the data in column. For example, take a origin column that contains the name of continents where the cars are manufactured. We will first find out how many continents are there in this column by applying unique function on this column. So you may see here there are 3 continents are there from where we were having a car. So there are 3 basically Asia, Europe and USA based car we are having in our data frame. Now we can also convert this value into the number. So for that regard, we have created one function. So here what we are doing, whenever there is a Asia will come, it will return as 1. If Europe will hit, it will return as 2. If USA will come, it will return as 3. Now after creating this function, now I am calling this function over here. So simply I am applying this origin to num function over the origin column. So after executing this command, you may see this origin feature, this origin column has converted into the numeric as per this modification. Now the next step of EDA which we used to do, that is a retrieval of data. To retrieve the rows and columns, we can use index-based located iloc or just locate loc method of the data frame class. So here the first one will give you the 0th row, the second command will give you the last row. It will select the row from 0 to 4 because this 5 is excluded. It will give you the all column and 0th, all rows and 0th column. This will give you all rows and initial 4 columns, right? So this is a outcome of that. Now we can also select the rows and column randomly as per the requirement by giving this value into list, right? So basically we are selecting 0th row, 2nd row, 4th row and 1st column, 3rd column and 5th column. So you may see this is the outcome of that. Now to retrieve first 5 row from a particular column, say 8th column, right? So here we are basically fetching the initial 5 rows from the 8th column. For that regard we use this iloc method. So this will give you the corresponding output of that. The same output can be obtained by using the loc method. But this loc method basically expects the column name. Here we have to tell the column name which we want to fetch. So after executing it, the same value we will get as we have obtained earlier. Now in dataset, in data frame basically, number of columns will be either string type or numeric type. So to retrieve only numeric type column, we can write all those numeric column name as like this. Let's say I only want to find out the numeric value. So you may see here we have already did this analysis by using info method. We are already having this information with us. So by executing this command, we have seen that these are the columns which are having a float value or integer value. So all this individual frame we can individual column name we can pass over here. So by passing and executing this command, it will give you the value of all the columns which are having a integer value or float value. But again, this this selection is a little laborious. So to get rid of this part, we are having a method called select_dtype. So this will make the task easy. Instead of writing all the columns names separately, we can pass only the required data type to select d types, right? So here we are passing include only float and integer. So by doing it, by default, all the columns which are having this specific type will come over here. Now the next step is to obtain the statistical information regarding the data frame. So we are having a method called describe. It is used to obtain some statistical data like percentile, mean and standard deviation of the numerical value in the column. It gives the statistical information for numeric type of column only. So to know the relationship between the numeric column, we can use correlation method on the data frame. So you may see here this is a correlation method, and here we have to specify the correlation method. Here correlation method we have chosen as Pearson. We can also use the Kendall and Spearman. So correlation basically give you correlation will give correlation among the numerical column and simply ignore the other column. So if you see this value, so the positive number indicate the positive correlation. So here there is a positive number. So if one variable value is increases, the other variable value is also increases. The negative, the negative correlation is is coming over here. It simply means that if one variable is increasing, the other one is going to be decreased. If correlation value is equal to 1, generally it comes when a variable a variable when correlated to the same variable in that case only this correlation will come as a 1. So if you see this in this example, engine size to cylinder correlation value is 0.908002, which is a positive, right? It means if engine size increase, the number of cylinder will also increase. If you see this engine size and MPG city, so here the value is coming as negative. It means that if engine size increase, the mileage in the city will decrease, right? So this kind of information we may have after after executing this statement. So this understanding we can grab out of it. Now, to find the correlation between all the column and MPG city, we can get it by executing this statement. So here you may see the MPG city is having a negative correlation with the engine size. This MPG city is having a negative correlation with the cylinder. Same thing is true with the horsepower. MPG city to MPG city, always it will come as 1. MPG city with the MPG high weight is a positive correlation, right? So this kind of understanding, this kind of information we can gather by executing such kind of commands. Now the last step of this EDA generally we perform by using graph or by plotting the two variables side by side. So that will give us the relationship among the, by doing that we can figure out the relationship among the different features, our input and output, like that, right? So visualizing the data in form of graphs or plot is basically helpful to understand the relationship between the columns as we have discussed. So to draw the distribution plot with the kernel density estimate, that is a KDE, we can use this disk plot function of the Seaborn module. So here we have passed the data frame and this column name, that is MPG city. Here we have specified the beans. KD is true, that is a kernel density estimate is true. That's why this density function is coming over here. Color we are keeping as a blue, right? So from this plot, we can understand that highest number of cars are giving a mileage in a range of this 15 to 20, right? So majority of the car is giving the mileage in this range, that is a 50 to 20. A smaller number of car are giving a mileage in range of let's say 55 to 60, right? So that kind of idea we may gather from this plot. Similarly, we can also create a regression plot that shows the regression line along with the scatter plot. This can be achieved using the REG function of the Seaborn module. So here I have given the x value as length and y is MPG city. So if you plot it, so if you observe this plot, the regression line shows the negative relation between the length of the car and MPG city. So when length of the car is increases, the mileage in the city is getting decreases. We can draw the box plot for the categorical variable. A categorical variable represent finite values. For example, the type column represent one of the 6 type of the car. So here in our case there is a SUV, sedan, sports, wagon, truck and hybrid. Hence type is a categorical variable. How can we know that type column has only 6 unique value? For this purpose, we are having a method called unique, right? So after executing it, we may have an idea that there are 6 different type of car we are having in our data frame. Now to know the relationship between type of car and mileage in the city, we can draw box plot, right? So here we have given the type and this MPG city, and to the box plot, this box plot method is available in SNS. So that is a Seaborn library. So from this box plot, we can understand that highest mileage in the city is possible in the case of hybrid car model only. The least mileage is given by what? This SUV car. Suppose we want to know the mileage of the car according to its origin, right? So again we use this box plot, and here at x-axis we have kept the origin, at y-axis we have kept the mileage, right? So from this plot we can understand that car manufactured in Asia is giving a better mileage than the other one. Now, so I mean, here we have to observe that the box plot are preferred when categorical data is being plotted. For example, type and origin are the column coming under the categorical data, right? So to understand the relationship between all the numeric type of column, we can draw the pair plot by using pair plot function, right? So this is the pair plot function. Here hue should be mentioned as any categorical variable. So hue or color will be changed depending on the the country name. I mean country origin, sorry. So here you may see this is the outcome of the pair plot, right? Now if you want to see this value in numeric, so for that regard we can use a heat map as well. So in heat map we have to given this data frame, and the correlation we have given and not is equal to true. Now this is the outcome of that. So you must see here that engine to cylinder there is a high correlation. They are highly dependent on each other, whereas cylinder and engine size, right, they are highly dependent on each other, right? So this kind of analysis, this kind of feature dependency we can check by using this heat map.
So today we have learned the concept. Now for the further better understanding, I have implemented the same idea by taking another suitable example in the next video. Thank you.